Hello, today we are solving this IIT trigonometric problem, and the question is, if a equals sine pi over 18 times sine 5 pi over 18 times sine 7 pi over 18 and x is the solution of the equation y equals 2 times greatest integer function x plus 2 and y equals 3 times greatest integer function x minus 2, and where x within these square brackets denotes the integral part of x, or you can say the greatest integer x, and we want to find out that a is equal to which of these four options, and it is a single answer correct question. Alright, so let's first look at the question and see what information we have. So we are given with value a equals an expression in terms of sines, and then we have two equations in terms of y, and whose solution is given by the value x. Okay, and here we are dealing with 2 to 3 different concepts, and let's first write those concepts. The first one here, if we write pi over 18 in terms of degrees, pi is 180 degrees over 18, that means 10 degrees. So the expression will change to sine 10 degrees, sine 50 degrees and sine 70 degrees. So the first formula or concept that we'll be using here is that if you have sine theta times sine 60 minus theta times sine 60 plus theta, then this expression is equal to 1 over 4 times sine 3 theta. Second, if you have two equations, y equals something in terms of x and another equation y equals something in terms of x, then from here we can conclude that x1 is equal to x2. Perfect. And the next concept that we'll use is that if you have a greatest integer function x minus n, then it can be written as greatest integer x plus greatest integer of minus n. Okay, now as we have listed all the concepts, let's go ahead and solve this. Okay, so the first thing first, a can be written as sine 10 degrees times sine 50 degrees times sine 70 degrees, and by using this formula we can write 50 as 60 minus 10 and 70 as 60 plus 10, right? So 50 is basically 60 minus 10 and 70 is 60 plus 10. So that being said, that means we can apply the first formula. So we'll write it as 1 over 4 times sine 3 times theta, and theta here is 10. So 3 times 10, so that is 30. 1 over 4 sine 30 degrees, and we know that sine 30 degrees is 1 over 2. So we have 1 over 4 times 1 over 2, and that's 1 over 8. Now we have the value of a, which is 1 over 8. Okay, so a is equal to 1 over 8. Now let's go ahead and apply this second and third formula to these equations. Y equals 2 times greatest integer x plus 2 and y equals 3 times greatest integer x minus 2. Okay, so as both are y values, so we can equate them by using that concept 2 that we discussed on the previous page. So we have 2 times greatest integer x plus 2 is equal to 3 times greatest integer x minus 2, and using the third rule that we have written here, we can write this right hand side as 3 times greatest integer x, let's write a bracket, plus greatest integer of -2, and the left hand side remains the same. And let's simplify this. So 2 times greatest integer x plus 2 is equal to 3 times greatest integer x, and greatest integer of -2 is basically -2, so that means we have 3 times -2, that is -6. And if we simplify this further, we can isolate greatest integer x terms on one side and constants on one side, so we'll get 8 is equal to greatest integer x. Okay, so here we have 8 equals greatest integer x, and previously we found that a is equal to 1 over 8. That means I can write a as 1 over greatest integer x. And if we look at the options, this is option B. So the correct answer is option B. I hope this video helped you. If you have any questions, you can post them in the comment section.